Hello students, we are studying matrices and determinant. This is lecture number 2. So in this lecture we will study what are singular and non-singular matrices and operations over the matrices. So firstly, we will study what are singular and non-singular matrices. So firstly we will write singular matrices. Okay, now to understand what means singular matrices, you must know how to find the determinant of the matrix that I have explained in the previous lecture. Okay, so the definition of singular matrices is that the matrix is said to be singular matrix if determinant of matrix is equal to 0. That is, if A is any square matrix means if the number of rows are equal to number of columns, then it will be square matrix. Then this matrix A, then matrix A is singular matrix if and only if the determinant of the matrix is equal to 0. Okay, for example, suppose I have this matrix 1 2 2 4. Okay, and if I will calculate the determinant of this matrix, so determinant of A, that can also be noted as determinant of A, that is mod of A. The determinant of this matrix will be 1 into 4 minus 2 into 2. So this will be equal to 4 minus 4, which is equal to 0. So as the determinant of A is equal to 0, this implies this given matrix A is singular matrix. Okay, one more example we can see. Second example, suppose I will take the example like this: 1 2 3 2 3 4 3 4 5. If we will find the determinant of this matrix, the determinant of A will be equal to, now to find the determinant of this matrix, now consider the first element, this 1, okay, and hide this row and this column. So what remains? This submatrix. Take its determinant. Okay, so what comes? This will be equal to 3 into 5 minus 4 into 4 minus, now this 2. Now hide this row and this column. What remains? 2 4 3 5. 2 4 3 5. So what comes? 2 into 5 minus 3 into 4. Okay, plus, now next element 3. Now hide this row and this column. So what remains? This matrix 2 3 3 4. Okay, so see what happens. This will be in plus 3 into 2 into 4 minus 3 into 3. Now solve this equations. This will be 1 into 15 minus 16 minus 2 into 10 minus 12 plus 3 into 8 minus 9. So this is again equal to 15 minus 16 is minus 1 minus 2 into 10 minus 12 is minus 2 plus 3 into 8 minus 9 is minus 1. So this will be minus 1 plus 4 minus 3. So this will be minus 4 plus 4, which is equal to 0. now as, now this is determinant of the matrix A, as determinant of A equal to 0, this implies A is singular matrix. Okay, I hope you understood what means singular matrix. Okay, now next thing is what means non-singular matrix. Non-singular matrix. Okay, now the matrix is said to be non-singular matrix if and only if the determinant of the matrix A is not equal to 0. This will be the reverse case of singular matrix. So in singular matrix, if the determinant is 0, and in non-singular matrix, if the determinant is non-zero. Okay, for example, if I will take the matrix 1, 2, 3, 4, okay, and if you will calculate the determinant of this matrix, that will be 1 into 4 minus 3 into 2, which is 4 minus 6, which is minus 2, and which is not equal to 0. Now, as the determinant of the matrix A is not equal to 0, this implies the matrix A is non-singular matrix. Non-singular matrix. Okay, second example we can see, this is first example. Second example, suppose I will take the matrix A equal to 1 2 0 1 1 1 2 0 1. Okay, and if you will try and find the determinant of this matrix, that is mod of A, so it will be 1 into, now what will be here, hide this row, hide this column, what remains, 1 0 1 1. So take its determinant. Okay, so what comes, 1 into 1 minus 0 into 1, then minus this one now. Okay, into, now hide this row, hide this column, what remains, 2 0 2 0 0 1. Okay, so take its determinant, so that will be 2 into 1 minus 0 into 0 plus, now this 2, now again hide this column, hide this row, hide this column, what remains, this submatrix, take its determinant. Okay, so that will be 2 into 1 minus 1 into 0. Okay, so solving this, so you will get 1 into, this will be 1 minus 0, that is 1 minus 1 into 2 minus 0, that is 2, plus 2 into 2 minus 0. Okay, so this will be 1 minus 2 plus 2 into 2 4, so this will be 3, which is not equal to 0. Now, as the determinant of the matrix is not equal to 0, this implies A is a non-singular matrix. Now I hope the definition of the singular and non-singular matrix is clear to you. Okay, you can solve some examples. I will give you for the assignment, okay, for your practice. Example, check the matrix is singular or non-singular. Okay, first example, matrix A is suppose 0 0 1 3. Okay, second example, matrix A is suppose 1 3 2 0 0 0 1 1 1. Okay, third example, matrix A is suppose 1 2 minus 1 1 1 1 2 0 1. Okay, fourth example, matrix A is suppose 1 2 3 1 1 1 minus 1 0 1. Okay, now check whether the matrix A in all four examples are singular matrices or non-singular matrices. Now in the next topic we will see the operations over matrices, operations on matrices. Okay, so firstly we will see equality of matrix, equality of matrix. Now if I have suppose two matrices, okay, suppose I have the matrix A and matrix B. Okay, suppose this matrix is of order m by n and this matrix is of order suppose p by q. Okay, now question is when the matrix are equal, when the two matrices are equal. Okay, so this is our question, when the matrices A, B or anything will be equal. Okay, so by the definition, two matrices are said to be equal if suppose they satisfies two conditions. The first condition is what? The orders of both matrices should be equal. Okay, means if I have one matrix of order 2 by 3 and one matrix of order 3 by 2, then they cannot be equal because the order is not same. Okay, so two matrices said to be equal, first condition is what? The orders of those matrices should be equal. Okay, and the second condition is what? The corresponding elements in both matrices should be equal. Okay, so if two matrices A and B satisfies both the condition 1 and condition 2, then only we say that the matrices are equal. Okay, for example, suppose I will take the matrix A, suppose A, B, C and D. Okay, suppose matrix B is suppose L, M, N and P. Okay, then I will say the matrix A and B are equal only when if they are satisfying those two conditions. First condition is what? The order of the both the matrix should be equal. Okay, now order of this matrix is 2 by 2 and order of this matrix is 2 by 2. Okay, the order of the matrix are same, matrix A and B. Okay, so it may be equal. Okay, and the second condition what says? The corresponding element in both the matrices should be equal. Okay, so the matrix A and B, so A will be equal to B if what should be equal? The corresponding element. Okay, this is A11 entry, this is A11 entry in the matrix B. So this A should be equal to L, this C should be equal to this M, this B should be equal to this N and this D should be equal to this P. Okay, then only we say that the matrix will be equal. For example, suppose I will consider the matrix A equal to 1 2 3 4. Okay, and the matrix B is suppose 1 3. Okay, now if you will observe, the order of this matrix is 2 by 2 and the order of this matrix is 2 by 1, so they cannot be equal because orders are not same. Okay, so not equal. Okay, so this is your first example. Second example, suppose I will take the example like this: 1 1 3 4. Okay, and the matrix B is suppose 1 1 1 4. Okay, now again if you will observe, the order of this matrix is 2 by 2 and the order of this matrix is 2 by 2, so orders are same, but orders are same, it does not mean they are equal. So next necessary condition is what? The corresponding element should be equal. Okay, now if you will observe, this one is equal to this one, no problem. This one is equal to this one, no problem. This 4 is also equal to this 4, no problem. But problem with this 3. Okay, this 3 is not equal to this one. Okay, so the corresponding elements are not same. It means that the matrix A and B are not equal. Okay, so this implies A is not equal to B, are not equal. Okay, third example, suppose I will take the matrix 1 2, okay, and the matrix B is suppose 1 2. Okay, now observe the order of the matrix. The order of this matrix is 2 by 1 and the order of this matrix is 2 by 1, and also the corresponding elements are equal. If you observe, this means that this implies A is equal to B. The matrices are equal. Is it clear? Now we will see one more example. Example number 4. Suppose I will take the matrix 1 0 1 1, okay, and the matrix B is again 1 0 1 1. Then the question is whether the matrices are equal or not. Now observe the order first. Order is 2 by 2. Here the order is 2 by 2. Now check the elements. Now this 1 is equal to this 1. Now this one is equal to this one. Now this 0 is equal to this 0 and this one is equal to this one. So corresponding elements are also equal. This implies A is equal to B because the order as well as the corresponding elements are equal. Okay. Now we will see one example over it. Example, okay, if we have the matrix A equal to 15 14 12 10, the matrix B equal to 15 12 14 10, okay, and the matrix C is suppose 15 10 14 12. Okay, now if you observe in this case, the matrix A is equal to matrix B because the order of this matrix A is 2 by 2, the order of the matrix B is 2 by 2, also the order of matrix C is 2 by 2. But if you observe for A and B, the order is 2 by 2, also the corresponding elements are equal. This means that the matrix A is equal to matrix B. But if you observe the matrix C is not equal to A or B. Okay, so matrix C is not equal to A, also it is not equal to B because the corresponding elements are not equal. Okay, this is first example. Second example, suppose if 2A minus B 4 minus 7 2 is equal to matrix 1 minus 7 4 A plus 3B. Okay, and the question is find the values of A and B. Find values of A and B. Okay, now in this example we have given the data. Okay, suppose this is matrix A and this is matrix B, and what they are saying, both the matrix A and B are equal. This is given thing. Okay, now as we have given the matrix A and B are equal and they have asked to find the values for A and B, means what we will do, as the matrix are, now we know the definition of the equal matrix, what the matrix will be equal if the order is same and also the corresponding element should be equal. Now they have given they are equal, means what, they mean what, this value is equal to this value. Okay, so this implies 2a minus b equal to 1 and this value 2 should be equal to a plus 3b and this 2 should be equal to a plus 3b. So solving these two simultaneous equations so that we will get the value for a and b. So the first equation is 2a minus b equal to 1 and a plus 3b equal to 2. So this is 2a minus b equal to 1 and a plus 3b equal to 2. Okay, so solving these two simultaneous equation, now we know, we studied how to solve the simultaneous equation, okay, by eliminating one of the variable. Okay, now in this case variable is a and b. Okay, suppose I want to eliminate this b. Okay, so what I will do, I will multiply, this is your first equation, second equation, I will multiply this first equation by coefficient of b. Coefficient of b is what, 3. I will multiply this equation by 3 and multiply this equation by minus 1. Okay, so this equation will become, therefore equation 1 become what, 3 into 2 6a minus 3b equal to 3 into 1 3 and equation 2 become minus 1 into a minus a and 3 into minus 1 minus 3b equal to 2 into minus 1 minus 2. Now solve these two equations. Okay, if you will change the sign, see what will happen, this minus will be plus, this minus will be plus, this minus will be plus. Okay, so this 3b will get cancelled. Okay, and 6a plus a will be 7a and this 3 plus 2 will be 5. So we get the value for a, that will be 5 by 7. Okay, now to find the value for b, we can use equation number 1 or 2. Okay, so to get b, I will use equation number 2. So from equation 2, what I will get, what is equation 2? A plus 3b equal to 2. So we get 3b equal to 2 minus a, that is, put the value for a is 5 by 7, this will be 14 minus 5, that is 9 by 7. So I get the value for 3b is equal to 9 by 7. This implies b equal to 3 by 7. Okay, you can cancel this 3 with this 9, this will be 3. So answer is 3 by 7. So finally I got the value for a equal to 5 by 7 and value for b equal to 3 by 7. So this is how we can solve the equation if the matrix are given to be equal matrix. Okay, I hope this is clear to you now. Okay, now the second operation on the matrix is that multiplication by scalar to matrix. Okay, now scalar means what? Scalar is basically a number which is not equal to 0. Okay, if you will multiply any matrix by any scalar, suppose let I have the matrix A is equal to, suppose, A, B, C, D. Okay, and K be any scalar. Okay, K not equal to 0. Okay, it is any number not equal to 0, then see what will happen. If I will multiply this matrix A by this scalar A, then what will happen? This whole matrix A, what is matrix A, B, C, D, has to multiply by this scalar K. Okay, so what this will become? Now when you are multiplying the matrix by the scalar, it means what? Every element of this matrix, will get multiplied by that scalar. Okay, so this will become K into A, K into B, K into C, K into D. Okay, for example, suppose I have the matrix 1, 2, 3, 4. Okay, and if I will multiply, or I will take the value for K is equal to 4, okay, which is not equal to 0, and question is find 4A. Okay, so to find this 4A, what I will do? I will multiply this matrix A 1, 2, 3, 4 by this 4. So what I will get? Every element of the matrix will get multiplied by 4. So 4 into 1, 4 into 3, 4 into 2, 4 into 4. Okay, so this will be equal to 4 into 1, 4. This will be 12. This will be 8. This will be 16. Okay, so this will be your answer. Okay, one more example. Okay, find minus 3B. Okay, where B is 1 minus 1, 3 minus 9. Okay, so minus 3B will be equal to minus 3 into B. B is 1 minus 1, 3 minus 9, which is what? Every element will get multiplied by minus 3. So this will be minus 3 into 1, minus 3 into 3, then minus 3 into minus 1, minus 3 into minus 9. So which is minus 3 into 1, minus 3. This will be minus 9. This will be 3, and this will be 27. Okay, so this will be your answer. This will be value for minus 3B. Okay, now next thing is next operation number 3, the addition of matrices. This is very important. Addition of two matrices. Okay, now the condition for the addition of the matrices is that the order of both the matrix should be first equal, then only you can add two matrices. Okay, so condition for addition of two matrices is what? The order should be same or equal. Okay, so for example, suppose I will take the matrix of order 3 by 2, and second thing, the matrix B of order suppose 5 by 6. Okay, now what will happen? The addition will not exist. Addition does not exist. Okay, why? Because the orders are not same. This 3 by 2 is not equal to this 5 by 6. So addition of A and B will not exist. Okay, for example, suppose I will take this matrix 1, 2, 3, 4. Okay, and the matrix B is suppose 1, 0, 1, 1. Okay, now addition exists or not? Check the order. Okay, so order of this matrix is 2 by 2 and order of this matrix is 2 by 2. So orders are same. This implies the addition will exist. Addition exists. Okay, now the question is how to add two matrices. Okay, how to add two matrices. Okay, So for example, suppose I have the matrix A, suppose A, B, C, D, okay, and the matrix B is suppose P, Q, R and S, okay. Now obviously the order of this matrix is 2 by 2, and order of this matrix is also 2 by 2, so we can add A and B. The addition of this matrix can be written as A plus B, okay. So I will write the matrix A, B, C, D, okay, plus P, Q, R, S, okay. So this will be equal to A plus P. What you will do while adding? You need to add the corresponding elements, okay. So this will be equal to A plus P, okay. Also this C will get added with this Q, so this will be C plus Q, okay. Again this B will get added with this R, this will be B plus R, and this D will get added with this S, D plus S, okay. For example, suppose I have the matrix A is equal to 1 0 1 2, okay, and the matrix B is suppose 2 3 1 and minus 3, okay. Then question is find A plus B, okay. So what is A plus B? So firstly you need to check the order of the matrix. If the orders are same, then only you can add two matrices. The order of this matrix is 2 by 2 and order of this matrix is 2 by 2, so we can add A and B, and this addition will be A plus B. So write down matrix A 1 0 1 2 plus the matrix B 2 3 1 minus 3, okay. So while adding you need to add corresponding elements, okay. So what will get added? This 1 will get added to this 2, so this will be 1 plus 2. This 1 will get added with this 1, this will be 1 plus 1. This 0 will get added with this 3, this will be 0 plus 3. This 2 will get added to this minus 3, this will be 2 minus 3, okay. So this will be equal to 1 plus 2 is 3, 0 plus 3 is 3, 1 plus 1 is 2, and 2 minus 3 is minus 1. So this is how we can add two matrices, okay. We will see one example, okay. Example, show that A plus B is equal to B plus A. Given the matrix A is given to you, suppose this is 1 2 minus 1 3, and matrix B is given to you, this is suppose 2 3 1 4, okay, and question is to show A plus B is equal to B plus A. So the answer for this question, okay, I'll write this as solution, okay, to show what A plus B is equal to B plus A. So firstly I will consider the LHS. So LHS of this equation is what? LHS is A plus B. So what is matrix A? Matrix A is 1 2 minus 1 3, okay. Matrix B is 2 3 1 4. Now first question should be whether we can add these two matrices or not, okay. If you'll observe here, the order of this matrix is 2 by 2. Now order of the matrix B is 2 by 2, so we can add A and B, okay. So the addition will be 1 plus 2, corresponding elements will get added. This 1 will get added to this 2, 1 plus 2, then minus 1 plus 1, right. Then this 2 plus 3, then this will be 3 plus 4, okay. So this will be equal to 1 plus 2 is 3, 2 plus 3 is 5, minus 1 plus 1 is 0, 3 plus 4 is 7, fine. So we got this LHS equal to 3057. Now consider the RHS, okay. RHS of this equation is what? B plus A. So what is matrix B? B is 2 3 1 4 plus matrix A is 1 2 minus 1 3. Okay, now again take addition of the corresponding element. This will be 2 plus 1, then this will be 1 minus 1, then this will be 3 plus 2, then this will be 4 plus 3. Okay, add corresponding elements. So this will be 2 plus 1 3, 3 plus 2 5, 1 minus 1 0, 4 plus 3 7. Okay, so what we have shown that by LHS and RHS, okay, both are equal, and hence the proof. Okay, so we shown A plus B is equal to B plus A. Okay, so corresponding to such a operations, we can find the answers for our questions. Okay, so in the next lecture we will study how to subtract and how to multiply two matrices. Okay, thank you.